Hello students, you are right now in the central workshop of DIT University, and today we have to introduce you to the machine shop of our central workshop. Now this is the entry of the machine shop, and we move forward. This is our machine shop. Now I would like to tell you what is machining. Machining is the process of removing extra material from a given stock to get a finished component as per our requirement or the drawing. Right? Now to get a finished component and for machining we need various machines. The most important machine for this shop is the lathe machine, which will be discussed in detail, and its operation will be shown to you very systematically, because the objective of this shop is to train the student how a lathe functions and how the various components are manufactured using a lathe machine. But to operate the lathe machine, we need various cutting tools. So to generate or manufacture a cutting tool, we need some other equipments. And now let me tell you what are the other equipments. Let us move forward. Students, now you see this is the machine for preparing a cutting tool. Because for machining we need a cutting tool, which is very important, and that is normally made of high speed steel, or maybe high carbon steel, or maybe carbide. But normally in your case we will be using high speed steel cutting tool for any cutting operation in this shop. To prepare the tool, we have to generate a particular type of profile in the tool. So this is the tool we have to use for machining, right? Means for cutting a rod. And you see there are some profile is very specific. It is, the material is high speed steel, of course, but this profile has got a very specific significance. Otherwise it will not perform the cutting operation. To generate this profile, we have to maintain 7 parameters. Out of these 7 parameters, 6 are different angles and 1 nose radius is there. How to generate out of this cuboid? We have to generate 6 different cutting angles to achieve our desired cutting tool. And this machine is known as tool and cutter grinder. Why it is a grinder? Because there is a grinding wheel. It rotates at a very high speed and performs the cutting operation, right? And it has been fitted with a universal type of vise. With the adjustment of the vise, we can get a different angle depending upon the orientation of the vise, right? In the same machine we can also generate the cutting profile of the drill, because this is the drill bit and the cutting operation is performed by these edges. These edges are created at a very specific angle, and for normal mild steel this angle is 108 degree, right? So this can be performed on this machine with a proper attachment, right? Students, this is the pillar type drill machine. It is a very common and simple drill machine. With this machine, what we do, we perform drilling operation. You all know drilling is making a cylindrical hole in a given job piece. This is a flange, you see, and this flange has got 4 holes. All holes are cylindrical. You remember, holes may be square also, but with the help of a drilling machine we can perform cylindrical hole can be generated, right? To generate this hole, what we have to do, we have to clamp a drill on this chuck. Then afterward, we set a particular speed. For different holes, we have to take different speed, and that can be changed by changing the belts on the pulleys, right? After that, we start it and compress it. Doing this operation, we can generate holes as per our requirement. And this machine is again very versatile. We can change the position of the bed, we can make it up and down, and we can change the different speed of the drill, and that varies for this machine from 375 revolution per minute to 3220 revolution per minute. This is the basic specification of the machine, and with this machine you can drill almost half-inch hole, you can say 12.7 mm hole. Students, this is the bench grinder, and the objective of this grinding machine is to remove unwanted materials from the job. Normally sharp edges are removed with the help of this grinder, but somewhere it is also used as a machine for sharpening or cutting tools. Maybe if some organization or workshop, they are not having a tool and cutter grinder, as I explained you right now, they can use this machine as a grinder, but this wheel will rotate as per your requirement at a certain speed, but you can generate the profile with the help of your skill only. To work on this machine, we have to compromise with the precision, and again we have to have very good skill. Then and then only we can generate a profile as per our requirement. Maybe it is sharpening of a drill bit or sharpening of a turning tool. Students, this is the tool maker's microscope, and the objective of this microscope is to precisely measure the various angles provided to the cutting tool. As I explained to all of you that how this angle is manufactured or ground on a tool and cutter grinding machine. Afterward, we try to check the precision of the various angles as per requirement. This putting the same cutting tool on this plate and focusing properly and traveling or adjusting the movement, the vertical movement, the x-axis movement and y-axis movement, we can measure the angle of the tool's edges, and that is very important. Here, for precision, 2 micrometers are provided, and the least count of these micrometers naturally 10 micron, and there is a rotary scale also, because to measure the precision of the angle we need a rotary scale, and that rotary scale is also vernier type. Students, this is the surface plate. Normally there are 2 types of surface plate. One is of cast iron and the second one is of granite. Right now we have the granite surface plate. The beauty of this surface plate is we achieve better flatness, and longevity of this surface plate is better compared to the cast iron surface plate, because in case of cast iron surface plate, due to temperature variation, climatic change, there are minor changes on its flatness. In case of this granite type, there is normally almost no change due to the climatic condition. Second, in case of cast iron surface plate, if there is minor damage on its surface, that is transmitted through the surface plate and the damage is affected on a bigger area rather than the damaged portion. In this case, if there is minor damage, that particular portion is damaged and rest of the plate is undamaged and maintains its accuracy. So this plate is basically flat throughout, and this is the dial gauge, and this is the dial gauge stand, right? What we do, if we want to check whether these two surfaces are parallel or not, we'll put it over here and we'll move this dial gauge on this. If the needle doesn't deflect, that means it is parallel to the surface. So putting the job on this surface plate, we can check the flatness, parallelity of the job. Second thing is that if you want to check whether this piece is perfectly round or not, right? Measuring with the vernier, we get the information at a particular diameter only, right? 3 times we measure 20, 20, 20, may not be perfectly circular. To check the circularity, what we do, we put the job on a vise V block, and then we put it over here, right? And we'll set this dial on this, just rotating this part, you can see like this, and we will rotate this part gradually. If the deflection is very small, then we can say this, the cylindricity is better, right? If it is beyond the limit, we can reject it. If it is within the limit, we can accept it. So this is the basic objective of the surface plate, to get precise inspection purpose. Students, this is the lathe machine, and because this is the most conventional type of lathe machine, it is also known as center lathe or engine lathe. The major components are the headstock for providing power, the carriage which carries the cutting tool and has the provision to adjust the various position of the cutting tool, and the right side part is the tailstock. Tailstock is to support a longer job, and the other major component is the bed and the leg, right? In this machine, we can manufacture any component which has got an axis of symmetry, right? See, this is a rod, it has got an axis of symmetry. This is a block, right? Of course it is inclined, but it has got an axis of symmetry. So normally any component which has got an axis of symmetry can be manufactured very comfortably on this machine, but in some cases blocks, square blocks, cuboid blocks can also be manufactured. That's why it is a very versatile machine and also known as the mother of all machines. The cutting tool is fixed on this tool post, and the job which is to a machine is clamped on this chuck. Basically our objective is to manufacture a specimen as specified in this drawing. You see, this drawing is very enlarged, but actually we have to make a smaller component. Just for clarification, this is given to us and to explain the various operations, right? First of all, you see, we have to make this component finally, and to manufacture this component we need first of all a drawing, second we need raw materials, third the measuring tools and cutting tools. If you go by this job, we find it is first of all rough side has to be turned down. So this operation, first operation is called straight turning, because straight. Second, afterward there is a groove. You see, here is the groove, and after that groove we have to make this slant, the frustum type of shape. That shape is technically known as taper turning. After that, you see, there is a gripping facility over here that is generated by a knurling tool. So we need knurling tool for that. And to clamp this raw material on the lathe chuck, we need chuck key. With the help of this chuck key, we open the jaws of the chuck, and then afterward we clamp it to rigidly fix the raw material on the chuck. Afterward, the cutting tool for performing the various operations, we hold this tool in the tool post as I explained in the introduction of the lathe. Once these operations are over, we will be using this knurling tool for the knurling operation. For precise measurement, what we do, we are using vernier calipers. Vernier caliper is a very important instrument for machining because the precision of this machine is very high. With the help of this, we can measure up to 20 micron, or you can say 0.02 millimeter precision. Students, when you start the operation, you must follow some basic safety norms because these machines are mechanical as well as electrical also. It's very dangerous, and a lot of students are working simultaneously. So the instructor, to support the instructor or to make the instructor or the tutor confident and explain the job properly, you all have to be very disciplined. And to maintain the discipline, first of all, you do some safety, industrial safety norms. First of all, you must be working on a dongri. Dongri is available over here in the market. We have to procure it and put on every day whenever you enter the machine shop, whether you're working or you're not working. As you enter, you put on it, number one. Number two, you don't unnecessarily tamper with any machine because anytime you don't know how they will be switched on, right? Number two, the components during machining becomes very hot, so don't try to touch it without the permission of the instructor, right? The surfaces are rough, knowingly it has been made, but again, if oil is dropped somewhere, you please inform the instructor to remove this or don't make it slippery. And chips are very sharp. Once you machine, the chips are produced during cutting operation. They used to be very hot and very sharp. So please don't try to touch it. Remove it with the proper methodology using a stick or using gloves or magnetic plate is there for this purpose, right? Shoes is a must for you, and if there is any doubt, you please immediately consult your teacher or the instructor.